Okay, well, let's make a start. Good afternoon, everybody. My name is Richard Tabner. I am chair of the Hearts and Beds Constructing Excellence Club and also director of RDT Architects. This afternoon, we have a exciting presentation on modern methods construction. We have two speakers. We have Phil Henry from Genuit, and we also have Richard Crosby from Black. Phil will be talking first. I've just got a couple of quick announcements. If you want to ask a question, if you'd like to put it into the chat function, which you can find at the bottom of your screens, we will then go through those questions at the end of both presentations, so right at the very end after we've had the two speakers. If we run out of time, we'll then pick up some of those questions at a later date, and that leads me into my second point, is that we also have, fortunately enough, a visit to the seismic project on Thursday the 26th of May. So there will be another opportunity there to ask more questions going forward. And then finally, I'll repeat this at the end, we're currently inviting entries to the Hearts and Beds Constructing Excellence Awards, and the closing date for that is Friday the 6th of May. And once that closes, we'll then announce the winners at the visit to the BRE on the 26th. That's all from me. So I'll hand over to Phil to start this afternoon's presentation. Thank you.
Thanks, Richard. Thanks for the introduction, and hello to everybody. I'm just making sure you can see the screen. Hopefully you can.
Yes, we can. I can see it.
Thank you very much. So this is a view from a manufacturer's view in terms of manufacturing and MEP solutions for the off-site sector from Genuit. What I wanted to also do with this is to give you an overview in terms of who Genuit is. So Genuit is the renaming of Polypipe PLC, which occurred last April. The number of businesses you can see on the right are part of the Genuit group. So lots of Polypipe names, but other names that do not resonance with any Polypipe, AD, Domus. So our main focus as a business effectively across those groups are water management and also indoor air quality. And our business basically is we're a UK manufacturer, about £400 million turnover. We manufacture in the UK and we're UK owned, and we're the last business to do that. So we're very proud of that heritage. But we do focus in three main areas, which is infrastructure, commercial, and housing and residential. And that is around water externally, water internally, and indoor air quality. So a little bit about the business, but in terms of modular, the area in terms of finally the Henry Ford moment has arrived for UK house building. So the presentation today is split into two areas. One is for house building in factories, but also using modular on traditional build as well. And the approaches are slightly different for each. And we're on a journey. So we're still experimenting with this as a business. And it's an ongoing, quite organic process at the moment. So as you can see with Henry Ford, a revolutionary tactic almost 100 years ago was, in terms of car manufacturing, was to pre-manufacture items that came down a conveyor belt in terms of the cars, gearboxes, brakes and elements. And also with the housing sector, we're almost arriving to that moment as well. Currently, with most of the house building, factory house building that currently is being undertaken, we feel that it's arrived for the modular world. Currently, the work, as you can see there, is undertaken in a factory environment. So they're still using traditional type skills, but in a factory environment, rather than using pre-assembled assemblies as you would do in a modern car plant. And that throws its own challenges up for a number of reasons. One is obviously the skills and availability of labour. There's intense competition between the existing factories and the traditional routes to market, i.e. the traditional build. And a lot of those workers are subcontracted into those factories as well. So one of the things that manufacturers are looking at is how can they become a sub-assembler to provide sub-assembly into the factory to be installed and then to be overviewed and tested by qualified electricians and plumbers. So we're not quite there yet, and it is a process. And in terms of our marketing is very similar. We're saying when you buy a watch, you don't buy it like the left-hand side and then put it together. And if you go for a pint of beer, you're not given a load of ingredients and told, go away, unless you're home brewing, go and make your own beer. So we want a finished item made up of sub-assemblies delivered in terms of fabrication. This is both for modular and for traditional build. So here's a great example in terms of what we've tried to model ourselves on. This is using sub-assemblies coming into, this is actually BMW factory. So the cockpit has assemblers putting together the cockpit area, which are produced by a number of specialized companies, and including the seats, the cockpit. They're not made by BMW, they're made by less specialist manufacturers that provide a sub-assembly. What they don't do is have a kit of parts on the top right, which is going on a lot of sites in terms of either loose fittings, cut pipe, and then someone putting it together. That's not how modern factories work in this sector. So we are trying to move the industry into an area of, one, awareness that it needs this, and then two, moving into the business model, which is quite difficult for factories to make that transition, especially when they've got orders to place. They've got deadlines as well, and they have to change that factory environment. So it's quite a difficult process, which has been our experience in this sector. So how do we do that? Very interesting in terms of engagement. So we're very much involved very early on in the process in terms of CAD/CAM technology. So as you can see here, a design in terms of a digital design, it's absolutely imperative that we have a model to work on, and then our detail as a manufacturer can be federated into that model. That's absolutely key. Without that, this whole process does not go anywhere down that road at all. The ultimate aim is to develop, as you can see in the third image from the left, is a sub-assembly of components to which on the right you have the actual built item built on that digital model. So for manufacturers, it means very much early involvement in the design process with the factory, but also with the consultancy, the MEP consultancy. And I can say on most projects, there is still a design of a standard design coming out, which then is interpreted by the manufacturer. But it promising and increasing, what we are seeing is the manufacturers and the consultancy sitting down very early on to design the actual sub-assembly rather than redesign, which makes a lot of sense. But clearly there are risks there for the manufacturer in terms of design and things like PI that they need to undertake for that process as well. So in terms of factory, this is the aim that we would want to come up with. And in this particular case, there are products there which are non-polypipe products, in particular there, the flushing system, and areas like liabilities have to be undertaken as well if you're sub-assembling an item of your own manufactured products and other manufacturers as well. So it isn't easy, but there are ways to mitigate that. Here's another example here in terms of design. So it's using the understanding in terms of ventilation, and we're also looking at standardization then of toilets, wash hand basins. What is key to this also is a design freeze fairly early on, but also having a standard product to be used in most locations. Most of the bathrooms, washrooms and kitchens, they're very similar in terms of their size and location of the appliances. So what we try and do is rationalize that so we can use standardized components as much as possible throughout the project. That helps us with stocking. It also helps the off-site manufacturer destock some of their loose components and then take in sub-assemblies which can be used in different house models. And that frees them up in terms of things like their cost for stock, and they're buying in a sub-assembly rather than a range of stocking components, which isn't very much value in that. That's the role of the manufacturer or the stockist to hold that, not necessarily the client. So this is a great example where the digital involvement very early on, both in ventilation strategy, also the hot and cold water distribution, air source heat pump, and also the sanitary ware as well. So this image here actually shows a live image which was developed during the Nightingale projects, but actually used on a couple of projects post Nightingale. So on the left-hand side is the actual physical finish. It's in timber. The reason for that was a client was building houses in timber. They didn't want a steel frame, they wanted timber frame. The right of that, you can see the model that was developed, which is the digital, in our words, the digital twin, in terms of one development to the other. And the actual layout of that would be etched, laser etched, so we know where all the fixings are. So it's an exact copy where the sub-assembly is put together in the factory and then delivered. In this case, it's two parts, and then it can be bolted together and the connections made so they're safe and secure. The connections in the red and blue pipe are pressed connections. So again, once they're made and they're pressed, they're located in place. There's no risk of those opening up with push fit type of connections as well. And they can then be put onto stillets, stillages, and then shipped, as you can see on the top right hand side, as a complete sub-assembly. So the process is a fairly intensive in terms of working with a client to show them what is possible, to look at the productivity that can be increased of taking away those existing operations on the shop floor, and look at the volume that they can actually obtain by the units obviously coming past on a rolling road, is using the sub-assemblies as quick as possible to get more units out the door rather than being snagged up with using traditional fit out of both electrics and plumbing. In terms of on-site, it's a slightly more mature market and a very different market. Here you can see stacks. These are HTP drainage stacks for tall buildings. This is on a 30-story building where they're putting as a sort of first fix. And this is a slightly different process to the earlier process we mentioned in terms of challenges. The challenges to industry are very similar. So a lot of statistics here are lifted from Mark Farmer's report, Modernise or Die from CIGB. So a huge amount of workers retiring from the industry, and understanding the levels that we need coming into the industry as well, but also the skills that we need for the challenge to meet that. And again, from Mark's report, our skill shortages, which was obviously post-Brexit, but then since then we've had COVID, of course, as well, and issues on the supply of material. So there was a storm before that, then certainly is a storm now in terms of labour shortages on site and amount of productivity that's needed. In addition to this, recently the report has forecast that London is one of the most expensive cities in the world to construct in, and that's linked to materials and obviously labour costs as well. So productivity is going to be absolutely key in this area of tackling high costs. So this is very similar to what we would see, pre-tested items, not made of loose components, but actually completely made as a sub-assembly and designed, and then they can be installed very, very quickly. Again, this is using a traditional build on site with as many MMC components that can be included, but the actual unit itself is not made off site. So our considerations in terms of probably both areas is cost predictability. As a manufacturer, we can say exactly what the material cost will be to manufacture the particular items, and then that governs obviously the labour costs, because we can tell them exactly what those costs will be to install and our labour cost to install that. Detailed design up front again is key. We'll have a basic outline we need a design freeze, and then we will check it against things like the current British standards to make sure it's compliant before manufacturing starts. Health and safety and CDM 2015 really were key in terms of lifting either heavy loads or putting together components on site. And some of the components need, for instance, with HDP, a heated source to weld together. These are all issues that need to be considered working on site, and sometimes in very, very cramped areas. The MMC also, in terms of the stacks, they're all pre-tested. And that's going to be something that one of the slides will come back to, is a massive advantage when you're actually putting together stacks and looking for tests. If you can imagine, in some of these stacks, you will have at least 100 stacks with multiple connections. You can imagine leaks are doing it traditionally. Leaks can occur at any particular stage. Also, the better use of the skilled workforce. There's no point in them putting together units on site when we can actually do that for them and then ship them in as a stillage floor by floor. They can actually then use people as assemblers to install the stacks, and then use skilled force to do the finalized testing. Detailed information before drawing. We'll have a detail later on, but basically we draw it in 3D. If we can draw it in 3D, we can make it. But also from a manufacturer, we can bring the manufacturing innovation to them, new products that are available that they may not be aware of. Planning is really key on this. So design and fabrication period have to be included very much more in upfront. So a typical design fabrication for our particular business will be around about 4 weeks. So that needs to be factored in terms of when you want to start on site, and that's on basis of the layouts being signed off, because no manufacturing takes place until the client contractor has signed off the drawings to say that's what I want made. So that program has to be allowed for in terms of working back and having the design freeze as well. Compatibility of components, again, really key. We see a lot of different components added together. Who takes liability? How are they fitted? Well, we can deal with that very early on. If it's our products or somebody else's, we can actually then bring ways of connecting them together with the approved way of connection. And for digital, we need an agreed language when we actually bring the digital platform forward in terms of the design, rather than everybody using different types of language. So that's a really key point. So all of these points are very similar to both on-site and within a factory environment. So our evidence, we carried out a case for fabrication on-site. So it was the first ever that we looked at a 360 review of 2 high-rise developments, 22 stories, 23 stories, and we looked at material costs, labor costs, inspection, supervision, and equipment. And this was done by a third-party consultant. And this was to understand all the full impacts, and some of the impacts that we didn't realize were an advantage to the contractor as well. And some of the information that we were able to share that came through the report was basic installation labor. So here we have an example of our HDP loose pipe, our PVC loose, and cast iron in terms of installation time against fabricated. And as you can see, there are significant savings with the fabricated fuse as against the loose component. So 838 days on this 2 particular projects, as opposed to 378 days. So a massive improvement on the project time as well. Supervision was really important. That was thrown up in terms of supervision on site and health and safety. And again, you can see here, supervision was fairly level on the loose components, but certainly on fabrication, it dropped significantly to 85 days from 264 days. And again, there's a cost associated with that supervision, of course, as well, which is really important. Site logistics, again, important on both installations. So if we're going into a factory, they would come in stillages. If they go to site, they're normally delivered in stillages per floor. So all of those components are ready to be installed very, very quickly in a program. But as you can see here, significant savings in days, almost half what it would be for loose components in terms of delivery to gate as well. What's not factored into this is obviously things like CO2 measurements, gate delivery. So in terms of basic HTP, we can see significant savings there in terms of fabrication, supervision, logistics, a reduction in tool costs. That's the tooling required to fabricate on site. HTPE, which does have some welding and some components to weld together items, they're reduced because you don't need those. And in terms of testing time was reduced to 25–30%. And that's really important. Added to this, things like fire protection would be included with us as well. So this report has been very, very useful for us. And we can distribute it. That would be useful to any members later on. And again, fabrication helps us with existing stack replacement. So with local authority work, where you're working in a occupied environment. A good example here is in terms of the different types of material, or all of our different types of material here, but actually pre-manufacturing the items means that there's less downtime, the clients are inconvenienced less, and more importantly, we have defined costs in terms of how long the material cost will be, and how long the actual toilets in a facility will be out of action as well, which is all really important when you're dealing with occupied buildings. As I mentioned earlier, we draw it to manufacture it, so a detailed drawing is prepared, and from that we have a bill of materials and then a defined cost, and that's absolutely key for us to make sure the client knows exactly what they're going to get material wise. And in terms of our fabrication growth, to give you an example of those stacks, generally they're 3 meters. Last year we completed 22,000 of those stacks in a year in our facility down in Kent, and that's grown significantly every year, and that's primarily down to cost surety, but also the availability of labour increasingly on sites. Where we've also used fabrication has been in this is for data centres. So this goes underneath the outlets, and these are data centres up in Sweden. So that large sort of bucket area with a white connector in there is a leak detection unit. And what tends to happen in Swedish and Nordic countries is it's either very cold, very hot. The outlets tend to move, and the outlets are normally strategically placed right over the servers. So not great planning. And this is one that we developed for Facebook, and effectively it's a prefabricated item. When the water actually drips through, if it does, it goes into a leak detection. It tells the operator exactly which outlet is leaking, and then they can go on the roof and rectify. And that becomes a standard, because downtime for the data centers, in particular with Facebook, the costs involved are absolutely astronomical. And offsite MEP goes into our civils business increasingly as well. So a good example here of recycled material being used as underground assets. And this is a project that we developed, which is a schematic from a consultant, which was using concrete. And effectively what we did with this is develop the proposal into this, where we have some pumping requirements for water. A platform as part of CDM had to be incorporated, and these tanks were normally circa 40 meters long, 3 meter diameter, for bulk storage of water for data centers, but it had to be pre-finished and ready to be delivered, functional, ready to go, and installed very, very quickly. So again, fabrication, offsite fabrication is, we undertake this at our factory in Loughborough. And the unit itself would look like that. So almost like a submarine length with turrets, pump stations on there, and bulk storage of water then, and then in segments joined together. And a typical segment like that would normally take just over a day to install, which is fully welded together, which is a lot faster than we would do in traditional materials. And lastly, with Cobham, we did some work with Rambol, which is looking at the two assessments of predictability. And here we've actually used, an option in A, reinforced concrete, or B, and in terms of the cutting down of the program and the costs, the selection was to go to a prefabricated tank, which was actually in this case installed in 3 days completely. So that's I think just on time, looking at the watch, I think Richard is
perfect. That's perfect, Phil.
timing and
Whistle stop tour. Love it.
Thank you.
I will just pass across to Richard to do his presentation. And just a reminder for people listening, there is the chat function. If you want to put some questions in there, we'll take questions at the end. Thank you, Phil.
Thank you.
Thanks, guys.
So if you want to stop sharing your screen, yeah. Phil. Yeah. Perfect.
Okay.
Second.
Yeah, we can see that.
Pops
up. Yeah, we can. Brilliant. Over to you, Richard.
He's actually showing a slideshow.
No, you need to, yeah.
You have to go into your start slide.
Slideshow, yeah, view slideshow.
Yeah.
There you go.
That's it, great, thank you.
Perfect.
Right, seismic. A few of you may have heard a bit of this bouncing around for a little while. So when I call it a new platform for construction, well, actually it is, because we've been, it wasn't really a platform before, it was something else, but I will explain all that. So seismic is a cross-sector platform solution suitable for schools, offices, retail, residential, hospitals, and a few more that we haven't thought of yet. And to prove it, we've built a demonstrator building, which hopefully you can all come and have a look at on the 26th, is it? 26th of May?
Yep, 26th.
26th of May, down at the BRE. We've built it not as any particular building, but as an exhibition space, which we fit out with all our learnings from the project to try and disseminate it across industry, so everybody can be aware of it, what we've done, learn from it, tell us we've done it wrong, tell us we've done it right, suggest all that sort of stuff. It's there to be picked apart. What we've learned from this is we believe there's a lot of things in the industry we've been doing the way because we've always done it that way. And when we challenge people, why do we do it that way? Why do we build in this sequence? Why do we do that sort of thing? It's very difficult to get responses back other than that's the way it's done. So we're there to be testing and pushing all the way through on that. So we might have a few things that we say in here which may either open eyes or raise eyebrows, but feel free to come and push back on any of that or challenge it with any questions. Some of it might be uncomfortable for one or two people, particularly those that have got business models and their businesses that have been developed around how things have always been done. What we've got here that I'm going to talk you through is one building platform system built to 2 different specifications, manufactured in 3 separate locations by 3 different manufacturers. I'll go through that again to explain it later. But, so I'm going to talk about who Seismic are, the collaboration people, why Seismic came about, give an introduction to it. I can't go into loads of detail because of the time, but we'll give you a flavour and hopefully you can go into more detail when you come to build it. And then the outcomes. Let's have a look. Sorry, I'm jumping ahead here. Right, so who are Seismic? There's a collaboration of these motley crew. The manufacturers of the various components have been Elliott, the Algeco Group, as they're now known, McAvoy Group, and Tata Steel. tough to steal a manufacturer here, you say. They're a product supplier, aren't they? Well, they're moving up into a different area now, which is quite interesting. So similar to how Genuine was saying, they are moving into a different, slightly different space, which I think we will see more of going forward from the big product suppliers. Together, we've developed the standards, the processes and testing and measurement to a level that's not been seen before in the UK construction industry. And with the expertise and knowledge of our academic partners, which are the Manufacturing Technology Centre, the National Composite Centre and specific Swansea University. So these guys are verified the stuff that we've been doing independently. So why seismic? Does anybody remember this from July 2013? 9 years ago. Seems like ages, but it was. They threw down the gauntlet to the government. They told us they want to reduce costs by 33%. How's that going? Faster delivery, 50% faster than traditional. Lower emissions, 50% lower emissions. And exports up by 50%. If we're honest with ourselves, how are we all faring against those? Got a bit of to think about that. This was 9 years ago, these targets were set. Right, here's where I start to get a little bit controversial. Modern methods of construction. I'll just let you take that slide in for a moment. We've had the gauntlet thrown down in 2013. We've had the Egan report, the Latham report, the Farmer report. We must have another report due soon. They're all saying the same thing about modern methods of construction, standardisation, DFMA, platforms. How far have we really come? Precast concrete invented by the Romans. Slightly after that, but I remember when I started the industry, not quite the dates on this slide, but not long after that, I was using precast concrete systems 20, 30 years ago. Clasp systems that were built at all schools in the 50s were fantastic at the time. But we've got the same things being rebadged as modern methods of construction. Yes, I'm sure some processes and digitization improved a bit, but the basic processes are all the same. You're just putting them together slightly more efficiently. And we will never get super efficient unless we change that basic process. We build because we're building wrong. We're building in the wrong sequence. We're creating problems with ourselves by building up in the air and then having to break materials down to lots of little pieces that fit. Lifting regulations, and then hoist them up into the air to fit them out. The closest we can see at the moment that's out there in terms of efficiency on site delivery is that of the world of volumetric construction. But we all know that has its problems. Apologies for the graphic on the right hand side, but I don't think anybody wanted to be named on this one. So on theory, the theory of building things in volumetric pieces goes in quick. It fits to the DFMA principles of fused component parts. But when you get scratch behind the scenes and have a look behind the curtains there, you will see very traditional processes happening. People fixing plasterboard up step ladders, or worse case may be in this photo, and it becomes very traditional. In theory, it should be, but the industry hasn't quite moved on yet. But the site installation, there's something in this. There's got to be something in this. A number of years ago now, we developed, as Black developed a kit of parts for the Department of Education for all their schools. This was a slide was all the primary school stuff that we did for secondary schools as well. We knew it was all fast to install. We developed that standard suite, Lego parts, if you like, doing that all to an off-site grid. But we realised that gave us a few problems. I'm just going to give you some background on this. I'm not going to dwell on this because this has been an old presentation, quite frankly. I'm trying to bring it to speed with the new bits, but we developed on. But when we did this, it flagged up a load of problems in the industry generally, what we need to resolve and move on faster. We developed the most efficient layout we possibly could with it. We've broken it all down into volumetric component parts, which got to at least 85% pre-manufactured value. Each of those component parts could be moved around and slotted around in different places, so we could use the same parts on a standard grid to produce multiple different layouts to fit the different requirements of different sites. These were just a couple of examples using exactly the same component parts. You could, just by introduction of one or two different variations of parts, you could then have multiple other parts. What came off the back of that then, back in 2017, to develop that component schools layout, we won a competition with Innovate UK to develop a standard frame and connector block to enable interoperability between manufacturers. So we've taken the inspiration from the humble shipping container, really. Because some of the problems we were having is that each manufacturer was doing something slightly different. The same, but slightly different, which didn't allow interoperability, which meant all your risk was with one manufacturer, which meant traditional companies, traditional tier one companies, didn't want to subcontract to them because there was too many eggs in one basket, too large portion of the work. What value were they really adding? And then you've got a manufacturer trying to be a builder, to very different business models, which we can come on to a bit later on. But by 2019, we developed a standardized steel frame and connector block, where some of you may have heard about the seismic name before. We developed that base system. It's a base system for cross-sectional platform system that had the potential to be used by any modular provider, de-risking the whole construction process for clients, in particular design teams. A lot of people do not like using volumetric because you've got to work with one manufacturer at the moment, where actually you don't want to. You want to work with, keep all your options open. You'll hear now and now again all these people saying, "Oh, you've got to engage with the supply chain." Absolutely, you do, but at the right time when it's best value for the client. One of the key things that we wanted to do is we developed a system that was both 2D and 3D in assembly. You saw from that previous slide, it was people were building these big cages, these volumetric units, and then fitting them out in a very traditional way. We wanted to develop the seismic connector block that we developed. Not only allowed it to be interoperable with other manufacturers, but allowed you to manufacture it in 2D form and assemble it into 3D form, either at the end of the production line or even on site, if it's more efficient to do that logistically. And therefore, they're paving the way to numbers of different sub-assemblies. So the original base frame that we developed at the time was 50% faster, we used 50% less steel, and 30% in lower cost, 50% less carbon emissions than the previous one. But we want to take it beyond that and turn it into a true platform system. So the frame itself, the connector block itself, we think of it as a platform system. It's like having a smartphone but no apps that work for it. It's just the phone. So what good is that? I don't know if you're all aware of the construction playbook. It's well publicised, but within the construction playbook, it says this. Product platforms comprising of standardised and interoperable component parts and assemblies shall be procured in favour of. Contracting authorities should collaborate to find opportunities, not only for their own platform solutions, but others that are cross-sector. And the platform should be interoperable with components across different sectors. And this was all following the House of Lords call for residents back in December 20. And it was when this was launched. There's been obviously the roadmap been produced since then, doing that. But this is what the government are now saying we've got to do. Are there any of you who work in the public sector? How many platforms you've started with procuring? So what we developed with, we had the base system, the frame at the bottom with the connector block, and we wanted to develop series of components in cassette form, 2D cassette form, roof cassette, floor cassette, ceiling cassettes, and then the wall paneling systems. So our platform does exactly that. It does exactly what the construction playbook says in terms of definition of a platform system. There is a lot of people out there saying their precast concrete system or whatever is a platform system. But look at the definition and look, is it really a platform system? Have you got a base system which is interoperable with other different standard subcomponents of systems? We've designed it digitally in one federated model, each of the different blends. We've got 3 different manufacturers, 3 different locations, as mentioned before. But to show the assembly process in a slightly different way, I'll show you. There's a series of components that are shipped in as cassettes. The floor cassette goes down, the internal wall cassettes units come in, and then the roof cassettes are dropped on at the end of the process. And those panel systems are pretty good on site. It's the framing system and the connector that allows that allows a pulse line to be developed for manufacturing, which has had some massive improvements in impacts on the whole productivity and speed in the factory itself. Just be trying to move on from the slide, which is so to demonstrate the whole true platform thing, we designed it digitally, designed it physically. It seems to be everybody's doing that these days, but we did it both ways. We had to do it that way because we've got 3 different manufacturers all coming together, and we had to overlay it. In effect, we did it. We built the thing 3 times. Built it digitally, physically in the factory, and then assembled it again on site. So the process involved the frame and the connector, the cassettes that come to that. The key part of this was the testing and validation. Now, if you think about how things are designed and developed in the traditional industry at the moment, very little is actually tested, validated. We rely on designers' design to do its job, and their PI backing it up, I guess. We don't often test things. You speak to the manufacturers, and before they launch a product, things are very, very highly tested before they do it. We don't do that in the further upstream construction industry. But as part of all that, we had to measure the work we've been done, and so on the platform system. Yes, we're doing it because the government's saying it, but we had to gather the metrics. We had to get the metrics in accordance with the Construction 2025 targets, which is the cost of it, the time of it, the carbon, and actually the maturity of it. How far can we go? Which route is it the right route, and what's got the furthest opportunity? And that's probably the bit that I find more interesting about this, is what is its potential, not what we're doing. What we're doing is scratching the surface. I think Phil used the word the Henry Ford moment in his presentation. It's very true, which I'll come on to very short. Just to give you a feeling of what we were doing, this is the roof cassettes we produced. This is it, Tata Steel's Shotton factory. We've got embedded PVs printed onto standing seam roof on there. To give you a flavour of what they look like. Notice they are made down at waist height, no climbing up heights. This is all the big cassette units moved around using machinery within the factory. Testing wise, we used some of the country's leading experts in their relevant field. We have burnt these cassettes, we've blown them up, we've sound bombarded them with various we've tested them from vibration testing, and this isn't just a jumping up and down on the floor, we all do, we've been to these buildings. This is what we've really tested. We've spent we've got 2 different specification options. On one of the options, we spent nearly £250,000 just on vibration testing alone to get a feel for what we're trying to do. This is tested. How often do you see bespoke one-off traditional builds tested? Too late, you build it. So from some of my lessons learned from the central government, I realised that it's all about the metrics. Evidence-based decision making is what they like to go on within central government. You have to prove it, and I've got the scars to prove it as well when we're trying to move and develop new ways of working within Department for Education and etc. etc. But you have to prove it, you have to test, you have to validate, and give people surety that it can be done. Which is why we've measured and benchmarked our achievements and had them independently assessed by academic partners. And these are the stats, the high-level stats that we have achieved. 40% better value. Now we're calling it better value against the 30% cost reduction because, quite frankly, who's going to offer something at 33% cheaper than anything else on the market? They're not. So you've got to do more for less. We've got to show it that it's better value. I'll talk you through some of that. Yes, we're 75% faster than traditional. We are 70% less carbon. And there's a whole piece on that I can explain. The real stuff you need to go and see the building for. There's lots of stuff in there and speak to the real experts on how we've done this and how we've tested all this. But these are the headline figures. In terms of the time, to give you a feel for it, yes, we know the site time's faster, but it's the design time when you standardise a series of components reconfigurable to it, and we've developed the pulse line, the manufacturing process, we can make it significantly faster. In fact, some of the stats that we've got in there were saying that in a traditional volumetric approach, it might take 50 weeks to develop a single secondary school equivalent of. We could get that down to 8 weeks by comparison, which is something it's almost unbelievable to go and understand it and see it. The 47% better value stuff, it ticks all the boxes. Phil's gone through a lot of that in terms of the off-site stuff that generally you're working on that are there. But you know, if health and safety is not one of them, no working at height, then you know I don't know what else is. It reduces your risk, it increases your production, it helps the design, makes the design easier. The traceability, we've got elements, we've even got Q codes on each of the different various components that you can scan and see where all the different components are, where they were made them, lots of detail on that. And the whole, I won't bore you with the details that we all get preached on about MMC. We know what the benefits are. This is about doing it. Reducing carbon is a really interesting piece of that. And a prime example is that I was referring to, we've been doing it wrong, or we've been measuring it this way, because we've always done it that way. We've been carting materials up to the top of a building in little pieces to then stick them back together again, because we've always done it that way. But interestingly, we look at our buildings, when we generally measure the carbon in our buildings, and I'm no expert on this, I'm playing back from others, but we don't tend to take into account the end of the building's life and what happens to that building at the end of life. Buildings are not built there forever anymore. I don't know about you, but relatively recently, I don't feel I'm bold, others may disagree, but when there's a bit, if you've been in the construction industry for a weird of time, you always remember one of the projects and you've been working on, but you remember it more when you start seeing them knocking it down, that you were involved in it. It just shows you that the design life of a lot of these buildings, not necessarily the design life, but the actual life of these buildings is much, much shorter than you think. And that's where the carbon ends up. It ends up in landfill. So you've got to start looking at how we measure all this. So when we use a platform system with standardized components that can be reconfigured, taken off, it's easy to assemble, it's easy to disassemble. You can use materials that can be reused in their existing state as a first and primary, and then recycled as a secondary, then you can reduce your carbon footprint massively. Just an interesting way of viewing the whole thing. But we cannot just measure carbon in the way of getting to site, and then in use. We've got to think about the in use. This is something that I personally quite fascinating. This was a piece of work that was done by the Manufacturing Technology Centre to look at the maturity of manufacturing in the construction industry as it is, and they realised that actually, if you take a traditional approach of carting small pieces of material up to the high end of the frame, top of the frame, the most you'll ever get is level 2 against this, which is a traditional process, traditional on-site process using some levels of prefabricated components. The next level is to create a static batch with some volumetry, starting to do that a little bit, and then moving into level 4. But level 7 is where we've all got to be targeting. We believe with seismic, which is a true platform system, that we're not quite at level 4, but we're getting there. And with take-up in a platform system, we can achieve level 4. And then once you get to level 4, then the productivity line starts to kick in, and then that increases further investment use. And we think that level 7 will be easier to get to. But getting over the hurdle between level 2 and level 3 is the real challenge in the market at the moment. I hope that's been nationally controversial enough for you, but we're the seismic team. My name is Richard Crosby from Black. We're the project integrators and lead on it. This was just some of the motley crew that helped develop the seismic over a period of 4 years in total, although there was a lot of work going on behind the scenes then. Like I say, this is at the BRE in Watford, and I hope to see you all there in May. Thank you very much.
Excellent. Thank you, Richard, and thank you, Phil. 2 very good and timed presentations, which moves us nicely on to some questions. Just looking in the chat, I think Kevin's been quite busy. I don't know whether I don't know whether it's worth. Kevin, do you want to actually ask those questions, or rather than me just read them out, and just to one to Phil to start with?
Okay, let's pick one of the 2 for Phil, and then so Phil, I was wondering where we've got to in terms of the traditional building process, where you're responding to the design compared to what we need to be, where the design is responding to pre-manufacturing solutions. And I just threw in a bit further down for anybody a comment that Richard made. I'm old enough to remember the PSA's MOB, method of building, where we had a whole set of pre-designed components which you actually could have done exactly what Phil's talking about with. So Phil, how do you cope with the processes that really don't get you involved early enough?
I think there's 2 areas. In terms of the housing, factory housing, there is evidence now that we are engaged much earlier in that process, but there are different reasons for that. One is there is a form of contract as a manufacturer being engaged in the project. So either it's a memorandum of understanding or some contractual responsibility to deliver, including some PI design. So we're very much involved contractually very early on in the design process, either preparing a design based on a consultant's design or working with a consultant jointly to design the layout first of all, so it's not repeat working. So that's encouraging, and that's working in areas where we've already tested the proposition and I can see the benefit. So it's an education process. In the traditional market, it's very different because we don't have any engagement in NEC type forms of contract design and build. We're a provider of components to a subcontractor in some cases. So in that way, it's very difficult to have these benefits of offsite early on. It's very difficult also to talk about innovation. So the strategy really from us as a manufacturer is to get involved much earlier if we can with the client or with the main contractor. Normally at early design stage, sort of up to stage C, the layout will be generic for space awareness. There's very little that will be connected to off-site if it's a traditional build with some off-site components going in. But our experience is that by talking to the client very early on, or the main contractor at appointment, is about waste, CO2, EPDs, skills. We can get some of the innovation available much earlier on, rather than the traditional route of supplying a component into our distributors and then going into the supply chain, which in our experience will never get that innovation right to where it needs to be, which is, you know, with the main contractor that needs to do, you know, with a design team to deliver the project.
And still presumably at the risk of being value engineered out or exchanged out when the tenders come in and the contractor starts to look at what he's going to do to make his profitability. As we all know, the process works.
For us, it doesn't work. I mean, early design, really, my experience, you know, having done this for many, many years, is that consultants up until tender don't normally want to commit to an MMC solution. They want to see what the best value would be for designs. So normally when the main contractor and the design team have the responsibility to deliver, that's probably when we need to sit down with our Revit and understanding the BIM coordination, and then actually talk about it. Because earlier than that, you're right, the work we could do in terms of specification generally is value engineered out. For me, it occurs when, you know, for the traditional build that we showed on some of the imagery, is where the main contractor has to deliver on time, but also with the costs, and they're looking for all of those solutions around carbon, skills issues. I think that's shifting the way we do business, is from purely, say, consultancy to both main contractor design and consultancy, so slightly different, and also engaging with the ultimate client, because increasingly ESG is playing a part of funding and resilience of funding as well. So some of the items that we've got in this range and other ranges within the business have to be brought to the attention of probably the client much earlier.
Thanks, Phil. Shall I ask a question of Richard and then stop monopolising everything?
Go for it, Kevin.
So Richard, I was wondering, so one of the problems with full-on pod manufacturers is the pipeline. It seemed to me that the component approach might help, and I was wondering if you're much less a hostage to the pipeline than perhaps those full-on pod manufacturers are.
Absolutely, because you're creating commonality within commonality each time, and you're creating a wider supply chain of components that can fit to a base system, which will allow you to aggregate demand across where the need is. So the base demand will be the frame, set sizes, so you know it's going to need a load of those. Then you can go to different manufacturers, component manufacturers, to do the individual pieces. So the volumetric guys turn into assemblers rather than anything else of those other component parts. You've got to start thinking this as about how the various components will only come together within the supply chain, rather than thinking a traditional contractor builds everything, because we know they don't, and a volumetric contractor won't be building everything in the future, because they won't. I mean, they don't do it now. They don't want to do it now because it's too risky. And that's been the problem for the market. We've got to reduce the risk for the market to take this up. This is why we're trying to do it.
I did some work with Unite very early on, and they couldn't even maintain their own process to suit the facilities they were building for themselves, let alone somebody else.
Well, the interesting thing, as we found when we studied all this, is that a lot of the manufacturers all do it very similar anyway. They're all within 100 mil of each other. So it's bonkers that we create everything brand new. We cut bits of plasterboard down to 1.2 by 2.4 sheets. They don't make them in that sheet. They cut them to that, and then we stick them back together again. It's bonkers.
Yeah. Cheers, Richard. Okay, Richard, I'll stop for a minute.
Thank you, Kevin. I don't think there's anything else in the chat side of things. I think I just asked, just really kind of feedback of where we are in terms of the industry. I mean, obviously there are challenges across the board to even build as we would normally do. So it seems to be kind of like a good opportunity to start to look at modern methods. Have you seen an appetite increase over the last 12 months in terms of people and projects coming forward to look at this as an alternative to how they would normally do it, because they can't do it like they would normally do? I don't know whether you want to do that one, Phil, first, and Richard to comment.
Yeah, we've seen that in both sectors. I think the factory housing is slightly more difficult because they have a business plan at the moment which is basically predicated on using subcontractors. But obviously, if you look at the projects that they're producing, that the steel frames normally produced very, very quickly using CNC machines and welded. You can use robotics for that. But if you look at the bottleneck that's occurring on the fit out from plasterboarding, electrics and plumbing, that's what's slowing down nearly all these factories. Investigating a lot of them, you get this sort of hourglass area where you get a bottleneck and then you want to try and get them out the other side in terms of delivery. The answer is to build another factory. Well, the answer is not to build another factory. The answer is to look at the processing. And I think the problem also is on MMC. It's not construction. It should be modern methods of manufacturing, because in a factory, they're manufacturers, they're not constructors. So they've got to look at lean process as we would do in our 27 factories about processing. And so we are seeing that sort of knowledge exchange, but it's in its infancy, I think, at the moment, Richard. Whereas on the traditional sites, as a business, we've been providing prefabricated items for 40 years. So it's not new. I think what is new is, as I say on the graph, we're doing over 20,000 a year, and we've got an increased team both in design and manufacturing, and a new facility. Is the shortage of labour, skilled labour, in various sectors means that the only way that most people who understand the prefabrication is that they understand that's the only way they can probably take on projects and execute them, and also have some cost surety, because then the labour can be controlled as well. Once they've got the materials under control, they can control the labour costs as well.
Thank you. Do you want to add anything to that, Richard?
Agree with all that. Construction's about risk. It's about managing risk generally. There's a lot more than that, but primarily it's a process with risk inherent in it, and we have to manage it. It's best to manage it out rather than just transferring it. Over the last number of years now, we've been rather akin just to push it down the supply chain, which is increasingly less able to take that risk, which is starting to create inflation and all sorts of things. We've got to look at different ways of how we manage that risk out, and by testing it and productizing things is the way to do it. We are seeing shift in the market. We are seeing clients promoting it. Certain central government are promoting it. The issue that market has at the moment is the business models that it has developed since time began. And breaking out of that is very difficult. I can say this very openly as an SME. It is very difficult for an SME to come in to take on the delivery of a 20, 30, 100 million pound project as leading it, because they haven't got that financial backing, that financial capability. So you're relying on old school processes and old methods of business models that have developed. And I see that as one of the biggest challenges in the industry we've got to get over. There's consultants that have sold their services on being the ones that oversee and administer those contracts. That's how they make their money. If there's no those contracts to administer, they can't make those money. The contractors are the big tier one contractors that are often classed as cash retention vehicles rather than anything else. They take money in from the client and they pay it out as late as possible in smaller parts as possible, and they go and do more profitable things with a bit of money in between. But please feel free. I'm trying to be controversial to create some challenge further down the line, but it's these sort of things that need challenging if we really want to change.
I agree. Thank you. I got another one from Kevin. It looks like a hand raised this time.
While I was typing,
last one then.
Just stick my hand up.
Last one then.
I was going to ask you about systemic risk, Richard. So you mentioned this is all a risk process. How are you getting on with the insurance industry? So for those who aren't clear, Systemic risk is a perception that the insurance industry have. If you do something over and over again and you have a problem, then you have that problem over and over again. Therefore, it must be more risky rather than less risky, which everybody else thinks is the complete opposite.
Yeah, they've got a lot to learn in that way, as you know, Kevin. We are trying to get around that by applying more and more common sense, by physically testing our components and warranty and creating warranty maps within the supply chain. It takes that responsibility. And one of the examples that has been cited that I think is quite a good one of how a different model would work is that of the Boeing Dreamliner. If anybody's into their aircraft, you will know that wings are produced in one country, the engine's produced in another, the tails are produced in a different part of the world, etc. And they don't come together and are cobbled together under a main contractor on the airfield. They are designed and set up in a way that can be brought together, and that risk is managed through the design process and the installation process, and it's a very different organizational structure. And I would suggest that the construction of a Boeing Dreamliner is slightly more risky than that of a building that's just going to be stood there and not do a lot for a number of years. So if one industry can do it, why can't the construction industry do it? And we still have insurers that insure planes, but not in buildings. It's a bit strange.
Thank you. Okay, I think that will probably draw the presentations to an end. It just leaves me to kind of thank Richard and Phil for their presentations this afternoon, and also thank Rebecca at Hearts Building Control for hosting the event. And for me, just to plug two more dates again. The closing date for the Hearts and Beds Awards entries is the 6th of May, Friday the 6th of May.